Hey there, thanks for joining us. This is the certification exam prep session on the 70-461 exam, Querying Microsoft SQL Server 2012. My name is Christopher Harrison. I'm a Microsoft certified trainer, independent contractor, SharePoint SQL kind of guy, and my Twitter handle is @GeekTrainer. And I'm joined today.
My name is Susan Ibach, and I'm also a Microsoft certified trainer, these days working up at Microsoft Canada. And my Twitter handle, of course, being a Canadian, is @HockeyGeekGirl.
That's pretty much fitting. I mean, you're also a geek and a girl, so it's pretty much spot on there.
Works out.
Absolutely. So what we want to do today is we want to help you get from your knowledge of SQL Server 2012 into being certified on Microsoft SQL Server 2012. And I think really when you get right down to it, there's sort of 4 basic steps to make that transition from just simply knowing SQL Server to actually being certified on SQL Server.
Yeah, absolutely. Take a look at this slide here. It's a nice way of sort of summing it up because, you know, most people go, I've been playing with SQL Server, I want to get certified, but they're not sure exactly what, you know, aside from knowing I know I've got to study, I know I've got to take an exam, they're not too sure really how to approach it. So we'll break it down into 4 simple steps for you. The first step you can see here on the slide, it says identify your certification goals. So that's really just figuring out what certification do I want to earn and what are the exams I have to pass to get that particular certification. Then you've got to figure out what are the gaps in your knowledge. There's no point in restudying what you already know. You know how to write a basic select statement with a where clause. Don't spend 3 hours doing that again. So find the gaps in your knowledge that are required for you to know in the exam. Then you can focus on step 3, which is filling the gaps in your knowledge by doing some effective studying, and then you're going to feel really confident to go in and take that exam.
Absolutely. So let's take a little look at step 1 here, which is figuring out exactly what tests, what exams need to be taken. Well, there's 3 exams to become a Microsoft Certified Solutions Associate on SQL Server. The first exam, 70-461, is going to be querying. That's what we're here to talk about now. 70-462 is going to be administering, and then 70-463 is data warehousing. And so you'll notice the numbers are relatively sequential there. And by relatively, I mean...
It's almost like they planned it.
I know. It's kind of funny there. So, but anyway, so 461, 462, and then 463. We want to take a look at the 461. So with the 461, really kind of what is there to know about that 461? Kind of what is it that they focus in on
right.
The 461?
And also what's the structure? Because if you haven't taken an exam before, you also want to know a little bit about the structure of the exam itself. Can you just back up one slide there, Christopher?
Absolutely.
Yeah, because I think it's important if you haven't taken an exam before, just have an idea what it's going to be like when you get there. So the exam's going to be 40 to 60 questions long. It'll take 2 to 3 hours. And of course, it depends on you. If you're that person who, you know, is people who are always good at, like, you know, finishing an exam in 20 minutes and left the room, they'll be done in 20 minutes on these exams too. And then if you're one of those people who reviews all their questions and is always the last one to leave the room, you're going to want the full 3 hours. So it kind of depends on your personality.
Yeah, I need a little bit of time.
Yeah. I admit, I was that annoying person who always left after 30 minutes. But yeah, so 2 to 3 hours is about the time you'll have to complete the exams. And generally, you'll find, I've never met anybody, I don't know if you have, but who actually said they felt like they didn't have enough time and that's why they had trouble.
No. I mean, really, nobody's ever come to me and said, oh, well, if I would have had 20 more minutes, I know I would have done better. I would have passed that exam. It just doesn't happen. Yeah. So don't worry too much about the amount of time that you're going to have on the exam. Trust me, you're going to have plenty of time to get through the test. And
of course, the other question people always have is, what's a passing score? So the passing score for these exams is 700. So if you score 700, you have the pass. 700 itself is good. And by the way, in the end, nobody cares if you're 700, if you get 950 or you get 700. You just want to pass. 700
is the new 1,000. In fact, if you score 750, you studied too hard.
Oh, come on. All right. So the next thing we know is let's take a look at the first exam and actually look at that 461 objectives. Can you bring that one up? I think I got a slide for that. So when you actually go to the Microsoft Learning site and you bring up the information on one of the particular exams, you can actually see the breakdown of the different topics that are going to be covered on the exam and the percentage weight that'll be on those different topics. And this can be useful because you can see if there's an area which maybe only 10% of the exam questions are on it, you know, don't spend 6 days studying that topic. Whereas if another area is going to be 40% of the exam, I'm going to spend more time studying it. For this particular exam, creating database objects makes up about a quarter of the exam at 24%. So that's going to be your creating creating tables, creating views, alter views, working with data, which is going to be your basic select statements, modifying data, your updates, inserts, and also troubleshooting and optimizing your queries. You do need to know something about the performance as well. And you can always see these objectives, and there's actually a link here on this slide that said, where you can always go look these up for the exam.
Exactly. In fact, people will often ask me what it is that I use for a study guide, and honestly, that's it, is that I will just simply go to the objective domain, that list of skills measured, and I'll read through it, and if there's something on there that I just don't feel overly comfortable with, if I'm not, really sure maybe even what that word means, then I know, okay, well, that's where I need to focus my attention on. So it's not necessarily getting in and taking a look at the stuff that I already know. I know how to join tables, but maybe going back and re-examining, say, the syntax for XML.
Or pivot or something, which you don't use every day.
Exactly.
And one of the things, we just looked on that slide, we covered the high-level objectives, but when you actually go to the website, the Microsoft Learning website, it actually gives you a much more detailed listing of what's going to be expected for you to know. When they talk about creating database objects, what does that cover? So you'll see a more detailed listing when you actually visit the site.
Yep. Okay. So step one, figuring out exactly what exams to take. Step two, figuring out what's on the exam. Step three, and this is the biggest one, and this is the one that we want to spend the most amount of time with, that is filling the gaps. So what we've done here is we've broken down some of the different topics into a structure that's just going to kind of flow relatively well. So we've got create our database objects, kind of how to get in, set up those views, data types, things like that. Querying the data, how do we actually get the data back out of the database? Modifying data, how do we put the data into the database? And then finally, last but not least, how do we handle that 4 very simple words that you, of course, hear from every single user, which is make it go faster.
Yeah, so why don't we jump in? Well, let's jump in right away, because if you're looking at taking this exam, and I'm assuming that's why you're here listening to us today, let's jump in and actually start looking at the topics and help them out to pass. What do you think?
That sounds great to me.
I like it. Okay.
All right. So let's start off by taking a look at how to create our database objects.
Sounds perfect. So if we take a look at this slide here, when we talk about creating database objects, if you're going to create a table, I'm not going to get into create table syntax. That you should already be fairly comfortable with. But one of the things you always have to remember, of course, is the different data types you have to choose from. So let's talk about some of the newer data types that have come out in SQL Server, or some of the ones you might not be as familiar with. You've got the XML data type, which allows you to store XML data inside a column. You've got the spatial data types. That's what a lot of people haven't encountered before. The spatial data types, there's 2 different ones. There's the geometry data type and geography data type. Geometry data type is really designed, think of it as storing XY coordinates. You have a grid and you're trying to describe the position of something on a grid. That's what you would use a geometry data type for. Whereas a geography data type is for latitudes and longitudes. I'm a geocacher. I'm into geocaching.
I actually didn't know that.
Yeah, I am into geocaching. And of course, when you do geocaching, it's all about latitude and longitude of the geocaches you're trying to find. So if I was building a geocache database, it was going to store the waypoints of my different geocaches. I'd be using the geography data type in SQL Server. Then we have, of course, the new date data types. Yeah,
the date data types I think are really interesting because in the past it was just simply date time and then short date time, and that's been expanded a little bit. That we do still have date time, and now we've got date time 2, which is going to give you a higher level of precision, which can sometimes be helpful. But the biggest thing about date time is that it's both date and time. It's got both those components in there. And sometimes that's exactly what I want, but there are other times when I really don't care about the time of day. That if I don't care about, what time did the product actually leave the warehouse and get shipped out, there's not necessarily any need to be storing that. And in fact, it can make queries more difficult to write. Because if you're using a date time data type, it's always going to have that time component.
Oh, the number of times, but I have been doing a query and I say, go get me the record where date equals 1st of January, and it comes back, says no records found.
Yep.
Because when I inserted the record with a default sysdate, it stored it with the date and the time when the record's inserted. When I say, go get me the record from January 1st or November 1st, it searches for November 1st midnight if you don't specify a time.
Exactly. It always adds that on. And so one of the nice things that Microsoft has added into SQL Server is the date and the time data types, where the date is going to be exactly that, just the date, while the time is going to be just the time. And so one of the nice things about that is when I'm going to perform those queries, if I'm just looking at the date data type and now I'm looking for everything on January 1st, all I have to just simply say is ship date equals 1/1/2013, and I know that I'm going to get back the records that I'm actually expecting, rather than that no records found.
And the last one, of course, it's really important for me up in Canada, is the date time offset. The date time offset is really important because it stores the time zones. So those are some of the key data types that you want to be aware of. Let's also take a look at some of the different constraints. So if we take a look at this list of sort of the constraints that you can choose from, you've got check constraints you can add to a table. Of course, that allows you to do things like yes/no type columns. You know, it's a yes value, it's a no value, or it must be greater than the value in another column. You know, I want to make sure the ship date is greater than the order date type logic.
Exactly. Although it'd be really nice to have a store where it ships before you actually order it, like,
yes,
you know, the Psychic Friends shipping network.
Yes, we're not there yet.
Not yet.
Maybe that'll be coming in the next
Exactly,
release.
yes.
Then we've got the primary key constraint, right, which is, of course, our unique identifier, and it means it's, as soon as you identify something as a primary key, that means it's unique and it must be not null, typically our ID columns. You can, of course, also only have one primary key per table, and by default, it gets a clustered index and all those little fun things.
Yep.
Then we've got the foreign key constraints, which we see all over the place, because you've got, you know, every employee is in a department, that department must exist in the department table, so we got the foreign key constraints, unique constraints, and the default values, which allow you, of course, to make sure that a particular column gets assigned a default value when you create a new record.
Yep. And you'll notice here on the slide the basic syntax down towards the lower right, which is just simply whatever my column definition happens to be, give the constraint a name, and then I'm going to specify the type of constraint that I'm looking for, so unique, default, and then whatever options or additional information that I want to pass along to it.
I was going to say, now the options. I do want to mention one particular option that I think is really important to remember when you're talking about the constraints, which is the on cascade.
Oh, yes, that's very true.
Yeah.
When you're talking about dealing with a foreign key, of course, a foreign key is going to be a column that will point to a column in another table. So, for example, my orders are going to point back to customers. Well, what happens if I say delete a customer? What am I then going to do with the orders for that customer? And you've got the options to cascade, where if I delete the customer, it will then delete the orders.
It's a little scary.
More than a little bit scary. And then the other one is to set it to default or null.
The default is actually you get an error message back saying, excuse me, you can't delete this customer because they have orders. But you do need to be aware of those different options, because that's the kind of thing you could get a question on.
Indeed.
Then, of course, constraints are a great way to make sure we've got valid data in the database, but there are times when we have to, of course, go to triggers, either because the validation rules we're trying to enforce are more complicated or something I can't do with the check constraint. You know, I'm trying to think of it. Give a brilliant example off the top of your head of when you'd have to use a trigger for the validation?
Yeah, one of the things about triggers as opposed to a check constraint is that a check constraint is able to look at values in a column. So, for example, like unique. It's able to look at values inside of a given row, like a check constraint, like, again, that ship date on or after the order date. What a trigger allows me to do is more complex logic. So if I need to look something up inside of multiple tables, or if I need to compare maybe 2, 3, 4 rows together, I can do that with a trigger, and that's going to give me much better capabilities when it comes to performing our data integrity checks. The other big thing that a trigger allows me to do is to change the way that certain SQL commands are going to work, and that's the instead of trigger. That with the instead of trigger, what I can do is, instead of you deleting it, I can mark, say, a product as discontinued or a customer as inactive. So my user will go in and just issue a delete statement. Behind the scenes, though, all that I'm going to do is I'm just going to make an update to that. And if you take a look over back on the slide, what you're going to notice is the syntax there: create trigger, instead of or after, and then the particular command, as, and then inside of there, what you're going to have is the logic for your trigger. One of the other interesting aspects of triggers is the fact that you can roll back the current transaction from inside of the trigger. So if you're doing any complex data checks on, say, like an insert, and you realize, oh, wait a minute, this isn't going to work, this isn't valid values, it doesn't match up with the data that we're looking for, we can undo whatever it was that the user was trying to do by issuing a rollback transaction inside of there. So our trigger is going to fire inside of the current transaction.
And that is important. That brings up to mind another point, which is the issue of performance. Because triggers, of course, if you do an insert statement and then afterwards a trigger runs and goes, oh wait, you weren't allowed to do that insert statement, and then it rolls it back, that's not the best thing for performance. So do use constraints where possible and only go to the trigger if you have to when you're doing validation.
Yeah, if you can do it inside of a constraint, absolutely do it inside of a constraint. And that is one of those things that sort of separates somebody who's, just familiar with the syntax and somebody who is eventually going to go off and get certified, is being able to make those types of decisions. And definitely something to kind of keep an eye out whenever you're studying and getting ready for the exam.
Okay, let's move on to views. So if we can take a look at
Take a look at, yes.
Hey,
there's a slide. Yeah, there we go.
Let's take a look at the slide where we talk a bit about some of the views. When you're creating a view, there are some restrictions you have to be aware of. A view can't be more than 1,024 columns.
Which I've always wondered, if you're going to have something that's going to return more than 1,000, if you've got something that's hitting triple digits, I really want to see what you're doing there.
Yeah, I would be a rather scary database. The view itself can contain only a single query, though that can be quite a complex query if it makes it up. It can be join statements, it can contain aggregates and things. The query itself must return a single table of results, and there are some restrictions on the data modifications. If you've written a query that joins across 4 different tables and is doing sum and having and group by statements, and you say insert into that view, it's not going to work. But if you're creating a view that just reads from a single table and it's a pretty straightforward select statement, then you'll be able to do an insert statement to the view and it will successfully insert into a table. So you do need to be a bit conscious of, would an insert statement work? Generally speaking, when you have things like joins and aggregates with sum, count, that's when you won't be able to do inserts and updates and deletes through the view itself. Then there's of course, you can't use things like the top end statement unless you add the order by when you write the queries for the views as well. And there's a few view options as well, aren't they?
Yeah, as a matter of fact, there are a few view options. One of the biggest is the schema binding option. And the schema binding option is what's going to tell SQL not to allow any changes to the underlying tables that would impact that view. So if I've got 10 columns from 3 different tables, I'm not going to be allowed to make changes to those tables that would get rid of or rename or otherwise modify those columns. And by the way, the big thing that you're going to be using schema binding for, not just to protect the view, is also if you're going to create what's known as an indexed view.
Yeah, I was going to say, that's absolutely the key part, because if you want to put an index on a view, the view has to be created with the schema binding option. That is really important because index views can be a very powerful tool when you get into performance tuning.
Indeed. One of the other things that you can also do with a view, if you want to protect whatever the logic happen to be with the view, is use the with encryption. Keep in mind, though, that if you use with encryption, nobody's allowed to see it, including the administrator.
Don't lose the script you used to create that view. Oh, that'd be bad,
Yeah, so you got to be very careful about using with encryption. On top of that, while we're on the encryption, it's always based on the last execution. So if I said create view, whatever the name is, with encryption, and then I go back 3 days later and I say alter view, and I leave off the with encryption, it's now not encrypted. So it's based on the last execution. So if you said alter and you left it off, even if it was created with encryption, that's now gone.
And there's one more. I was talking a bit earlier about when are you allowed to update views and insert through views. There's an important option that will also affect what you're allowed to do when you're trying to do things like update statements through views. And that's the with check option. The example I always think of is, imagine if I am Hockey Geek Girl. I make a table that contains information about hockey players. And they're only players from Canada because, that's all the best players, of course. And so I create a view that says, select all players from players where country equals Canada. And then you go into the view and you say, update that player, set country equal to USA. Now you're updating it through the view, but what's weird is after you do that update, you wouldn't be able to see that record anymore through the view, because the view only shows people from Canada.
Yep. Yeah.
So if you specify with check as your option on the view, you won't be allowed to make an update that basically updates the record to something you can no longer see through the view.
Yep. Yeah, it does seem very appropriate to use an analogy with hockey players and check. I did rather enjoy that.
It's like I planned it.
Yeah, like maybe you've done that before.
All right, I'm going to pick on Christopher here. I want to bring up this slide. I got a question for you. See if you can get a sample practice question. Start thinking about how they're structured. So you're a database developer. One of the requirements is to create a searchable map of floor plans to allow customers to determine where items are stored. What data type will you use?
What data type? All right, so it's a good question. So one of the big things, and I want to use this a little bit actually as sort of a learning exercise, and let's kind of talk my way through this, because this is one of the things that you want to be thinking about whenever you're looking at a question, is, all right, well, maybe I don't know this. I'm looking at this and, my brain has just gone blank. Okay, now what do I do? Well, one of the big things that you want to do is figure out, okay, well, what couldn't it be? So we've got var binary and we've got big int in there, and it really can't be big. I mean, trying to make that searchable and workable with big, okay, that's not going to work. So we can get rid of that one right away. The next one there, var binary, I'm now going to start with blob, like, JPEGs, and then try and, no, that's not going to work. So we can get rid of those two. And so once you've done that, now you've made it a 50-50 shot. Hey, you know what? 50% chance I'm going to get it right, 50% chance I'm going to get it wrong. When all else fails, I can just guess. So now we've got it down to geometry, geography, and I'm trying to remember, and I was paying attention when you were talking earlier, which is a good thing.
Glad to hear it.
Yep. And if I remember, geometry was flat spaces, XY. Geography, because you said you're a geocacher, is the whole globe and all of that good stuff. So I'm going to say geometry. Final answer.
And that would be correct.
All right.
All right. Give the man a prize.
Excellent.
All right. Cool. Why don't we go on to the next topic that's covered on the exam, which is querying data.
Yeah. So now that we've actually created our database, it's now time, of course, to turn our attention to actually pulling data back out of the database and manipulate and work with that data. And SQL Server 2012 has a lot of cool new functionality when it comes to working with data. One of my favorites is the try statement. You'll notice actually that there's a try convert and a try parse, which we'll talk about in just a couple of moments, where try convert is just like a normal convert operation, where what I'm going to do is I'm going to specify the data type that I want to convert to and then the value that I'm looking to convert. Now, usually, if you say convert, and maybe I said convert and my data type was date, and I passed in a value of Wibble, well, SQL's not going to be able to convert that to a date.
I never know what to do with the Wibble data type.
Exactly. And it's not going to get you out of the Army, that much I can tell you. So SQL's not going to know what to do with that, so all it's going to do is just error out. And that can really be a pain. So that's where that try convert comes into play, where SQL looks at it and it goes, I don't know what you're trying to do, dude. It's just simply going to give me back a null value, which can be a much better way to handle those types of challenges. Along those same lines, one of the other challenges that we wind up running into is how to format, in particular, dates. Because, of course, in the US, whenever we structure a date, it's month, day, year. Basically, anywhere else in the world, it winds up being day, month, year.
Yeah, I went to a French school. It was day, month, year for me. Yeah.
Exactly. So if I say, February 1st, I say 2/1, that's, February 1st in the US. If I go anywhere else,
it's January 2nd.
Exactly. So that's where that parse command comes into play. What parse will allow me to do is it will allow me to say, all right, well, this is the value that I have, this is the type that I want to convert it to, and this is the culture that I want to use. So if we're dealing with, say, French, if we're dealing with, say, German, and anything, any other culture where that's going to be reversed, I can go in and specify that. You can tell I'm American. I say it's reversed, of course, for everybody else it would be, the way you're supposed to do it there. Now, right along with that parse, we've got try parse, and try parse is just like try convert. So if I say inside of try parse that I want to convert to a date, I pass in that value of Wibble, again, the try parse is going to give me back null, while parse would just simply error out. You can also use SQL to help format your data, get it ready for the outside world by utilizing format. And again, you can specify your culture. So if I'm getting the date out of the database and I need to make sure that it's proper for US, for Canada, for wherever it is that it happens to be, then I can utilize format. Last but not least, and all the VB developers and Access developers are going to be very excited to see this, we now have an instant if. Instant if is going to have 3 parameters, where the first is going to be some Boolean expression. The second parameter is what's going to be returned if it turns out that the Boolean expression is true. The third is what happens if it's false. So that way, if you don't want to build up that full case statement, if you don't want to build up that full if statement, you've got that instant if, which can make your queries just so much easier to read.
Yeah, and let's be clear, too, we're not listing all the SQL functions right here.
No.
But we're trying to highlight some of the ones that you might not have seen before because they're just new to SQL Server 2012.
Exactly.
Yeah. Say the ranking options, though. That's another one that not a lot of people have played with, but if you're trying to get certified, you should be aware of these ones as well. Things like the rank and the dense rank.
Exactly. Yeah, because with the ranking options, just to pivot on that just slightly, with the exam, one of the big things to keep in mind is that even though you might not necessarily work with it all the time, there are a lot of people out there that are working with, say, like the ranking functions or XML or otherwise, and so those are testable. So you always want to make sure, even if you haven't played with it a whole lot, that it might be testable. Make sure that you go in and study up on that. So coming back to then our ranking options, you'll notice the ranking options that we have up here. We've got our rank, we've got our dense rank, we've got our entile, we've got our row number. First up is the rank and dense rank.
Yep.
So the difference between rank and dense rank is with rank, if I have a tie between 2 items, so we're going to rank them, so first, second, third, fourth. Well, let's say that we're doing it by list price. And it turns out that we've got 3 products that have the same price. What's going to wind up happening is rank will give the same number to each one of those. So if we have something that's the most expensive and then 3 items that are tied for the second most expensive, with rank, it'll go 2, 2, 2. And then finally that 4th item, or 5th item, it's 5th item, it's going to put in the number 5. So we'll actually skip 3 and 4 there. The analogy that I always like is if you think to the Olympics. In the Olympics, if 2 people tie for the silver, they don't award a bronze medal, that it's just simply gold, silver, silver. With dense rank, it's just like rank. The difference, however, with dense rank is that it's going to not skip any numbers. So with dense rank, it would be 1, 1, 1 if I had 3 items tied for first, and then the next number thereafter is going to be 2. The next one that we've got is entile, and entile will give me the ability to create equal groups. So with entile, I'm going to specify the number of groups that I want to create, and SQL will automatically go in and create those for me. The big thing to keep in mind with entile is that this is not going to be bell curve, standard, no statistical analysis here. It's just simply going to be, these are the number of groups. So if I say entile 10, and I have 100 rows, making the math easy for myself, I'm going to get back 10 groups of 10 rows. Or if I had 100 rows and I changed it to 5, now I'm going to get 5 groups of 20 rows. That's all that it's going to wind up doing.
Yeah, and it's not statistically significant or anything. It's just a way of breaking the data up.
Exactly.
And then you've got your basic row number, which simply is going to say, you know, you execute your query, it's going to simply give you row numbers to the results.
Yeah,
very simple.
1, 2, 3, 4. Exactly.
Yeah.
Yep.
And now, of course, you cannot cover a SQL exam without covering joins.
No.
No. That's a given. You've got to have that on there.
Yep, exactly.
So you're going to have your basic inner joins, which, of course, you know, those are the ones you're familiar with. You're executing those every day. I just want to find the employees and their department information. I need to match each employee with its corresponding department, so I use an inner join. Those are the ones you're probably already very comfortable and familiar with. You probably don't need to spend a lot of time studying those. But then you've got things like the outer joins. What if I want a list of all my customers and all the orders they've placed, but some of the customers have never placed an order? If you do an inner join, you would only get back the customers who have placed orders. If you want all customers, all the orders they've placed, but I still want to see customers who didn't place orders, then I've got to go to an outer join.
And remember with your outer join that you've got left and right. And don't be confused about left and right. This is one of the things that you know, always throws people.
It is, and
yep.
It's a 50-50 chance of getting it right at least.
Yeah, there you go. It's either left or right. There's no difference at all, of course, between left and right. That the only difference between left and right is that it's going to point at the table that I want the extra rows from. So if on my from line I list customers first and then orders second, so going back to your analogy, if I want to make sure that I'm getting those customers, then I'm going to say left, because I listed it first, pointing at the table that I want the extra rows from, rather than right. And that is definitely one of those that you want to keep an eye out. And when you're going through and seeing those types of questions, be very careful about that, because sometimes you might decide that you're trying to set some land speed record and you're trying to get out of the exam in that 20 minutes, you know, and you're just going too fast. You've got to be very careful about reading the entire answer, looking at the syntax, because if I'm trying to get my customers, and I had customers then orders, and I said right, that's going to give me all the extra orders, but not going to give me the customers, and that's really what I'm looking for.
All the orders you had no customer, which is probably not going to help a lot.
No, it probably wouldn't give me anything. In fact, it might be a way to find that I've got bad data, but that's a conversation for maybe another.
That's another story. Yeah. So what about the full and the cross joins?
You know, so the full join is for a situation where I'm going to do a join between two tables, but it's possible inside of those two tables that maybe I've got items in one that don't match up to the other, items in the other that don't match up to the first, and that's where full comes into play. So it's basically a combination of a left join and a right join, as well as, of course, joining all of that together. Last but not least is a cross join, or better yet, a Cartesian product, which just sounds cooler if you say it that way.
Yep.
And honestly, I like that name better than a cross join, because there really isn't necessarily a join happening. It's not really bringing these two tables together in a meaningful way. All that's going to happen is that all the rows from one table are going to match all the rows from the other table, which is a great way to generate just, you know, a whole bunch of test data.
Yes,
absolutely.
Piles of test data.
You know,
yeah,
it's also a great way to bring your SQL Server to a crashing halt.
Yes.
But well, we'll talk about that.
Yeah,
another
you just
time.
imagine you do a join of, you know, coming back to my hockey. I've got a table with all my hockey players. I've got a table with all my hockey teams. If I do a cross join, it's going to tell me that Daniel Alfredson, one of my great Ottawa Senators, but he plays for the Senators, Vancouver, Washington, and it's going to list every single team. Then it's going to go to the next hockey player, and it's going to say they play on every single team, because it combines every record in player table 1 with every possible record in player table 2.
Which can sometimes be helpful, maybe for a little bit of troubleshooting, seeing what's going on behind the scenes. But for the most part, the biggest reason that it's there is just being able to generate test data.
Now, what about the apply operations?
So the apply operations basically allow me to join on a function. So let's say I create a function. It's going to take in a parameter, and maybe it's going to give me back the most recent order for a particular customer. Okay, cool. That can be very helpful. Well, the problem that I have is if it's taking it as a parameter, how do I then join that? So I've got my customers table with their name, their address, and I want to get that most recent order date. How do I get that in one query? That's where the apply operator comes into play. The apply operator comes in two different varieties, two different flavors, if you will, that I've got my cross apply and my outer apply. Now, the outer apply is going to behave just like an outer join. I always remember that, outer, outer. And if it turns out that somebody inside my customers hadn't placed an order, so it comes back as null, it's going to still return that customer. The cross apply, however, and basically what I always remember about this is that it's the exact opposite of a cross join. That with the cross apply, it's the only way I can keep it straight in my brain. The cross apply, what that's going to do, of course, is that's going to give me back only the customers that had actually placed an order. So when we pass the customer ID into the function, unless that function's returning data, we're not getting it back. So again, kind of bringing this back to getting ready for the exam, make sure when you're reading through that question that you understand exactly what that objective is, so that way you're using the right apply operator, and going back, you're using the right join as well.
Now we're talking about joins. Let's bring up a slide talking about the common table expressions, because it's a really nice lead-in.
It definitely is.
I'll go. Give me a look. You're talking, am I talking? Apparently I'm talking.
All righty.
All right. But the common table expression is a great way, and the syntax is really the key thing. But the common table expression, it almost, in my brain, I think of it as almost as having a temporary table based on another query.
Yep.
And then I immediately query that temporary table. And that's sort of how my brain sorts it out. So what I do is I have to come up with a name for my temporary table. So in the syntax on this slide here, you see it says with customers with orders, customer ID. So what I'm doing is I'm sort of creating a temporary table called customers with orders, and it has a column, customer ID.
Yep.
And then you see in the brackets the query that is going to create that temporary table. So that the customers with orders table is going to have the results of that select customer ID from sales all to customer. Then after the bracket, I'm now querying this temporary table that I had created. So now I have a select statement that is actually joining this temporary table to another table.
Yep. Yeah, and you'll notice that you can use it just like you would any other normal table inside of there. So if I wanted to do a union on that, if I want to do a join on that, then I've got that full power. I love CTEs. It makes it so wonderful to be able to break down kind of more complex queries.
What I found is when I first came out, I found them so confusing. But as soon as I got the hang of them, I found myself using them everywhere.
Absolutely.
It is worth taking the time. If you haven't mastered those yet, go play with them. You will love them.
Yeah.
They're addictive.
Yeah, they really are.
Yeah.
Now, inside that CTE, if we go back to the slide here real quick, I want to highlight the syntax that I've got inside of there and kind of use this as a real quick learning opportunity that Microsoft introduced into SQL Server, this is a couple of versions ago, intersect and accept. And what's cool about intersect and accept is they give us the opportunity to take two separate tables and find out, well, what rows match or what rows don't match. So you'll notice in the example here that we're using a customer table and an order table. If I put intersect inside of there, that's going to find me every single customer ID from the customer table that matches with the sales order header. On the flip side, if I change that to accept, it would give me all the customer IDs that don't match inside of there. So that's the difference between the intersect and the accept.
Yep. Then, of course, we've got to handle null values. That is, of course, the bane of every database developer's existence.
Yes.
You've got to handle the different null values and how do you deal with that when you come up with it in your data.
Yep. One way to do that is just to go ahead and write a case statement. You know, not necessarily always going to be the best way, but it can be nice maybe if you're looking for a little bit more complex logic there. If all you want to do is just look for null value, you've got isNull and you've got coalesce. And the big difference between the two, with isNull, it's going to be two parameters. If the first is null, it's going to give me the second. With coalesce, it's going to give me the ability to have multiple parameters, and the first one that's not null is going to come back.
Yep, exactly. Then what do we got? We get maybe pivots and then rollup.
Yep. Yeah, so one of the big things if you're going to be writing queries and aggregating data together is trying to get it ready for your actual salespeople, managers, and otherwise to be able to view this. And one big way is to do pivot. Now with pivot, what you're going to do is you're going to take what would normally be row data. So for example, in my little query here, you'll notice up at the top I've got my CTE, and then we've got our year with the sales year. That's going to be row data by default. What we want to do with pivot is we want to convert that into column data. So you'll notice the syntax down at the bottom. I'm going to pivot sum sales amount. So my sum of sales amount is now going to become the ooey gooey creamy center there. That's now going to become my data.
Well, basically, you try to show the total sales for each year.
Exactly. That's the more technical way to say it rather than ooey gooey center. Then what we're going to do is we're going to convert sales year, all the values inside of there, to be columns. And the big thing to remember about the syntax is that you do have to call out every single value that you're expecting inside of there that you now want to become columns. So you'll notice that we're saying 2001, 2002, 2003, 2004. That's now going to become columns. The one last column that we didn't call out on there was territory name, and that's going to become my new column on the far left. So what I'm going to wind up with is one column for my territory name, one column for 2001, 2002, 2003, 2004, and then in the middle, all of my sales amount, or my ooey gooey creamy center there.
And then you get into rollup and cubes, which are other nice things that we don't necessarily use every day, but can be very powerful. So we often will use aggregated functions like sums. So you've got, select region, country, category, and the sum of the total sold from sales, and you add a group by statement. And then, of course, you would get the total for each region, country, category. But what if you want the totals per region, per country, and per category as well? And that's when you want to go to the rollup.
Exactly. What rollup is going to do is rollup is going to make one pass. It's basically going to assume a hierarchy. So region, country, category. So it's going to assume that hierarchy. So it's going to give me the total for region, it's going to give me the total for region and country, it's going to give me the total for region, country, and category. If I instead say group by rollup, and I'm going to be slightly unprofessional here, only because I am noticing that there is a typo.
You're thinking that should be grouped by cube or something?
Yeah, there's a typo on that slide. Don't mind me.
Do not look at the man behind the curtain.
Exactly. Naval editing there.
All right.
All right. Yes. Do
I have to start juggling now to distract them while you're editing the slide?
Look over here. Okay.
Now, as we were saying, what were you saying about the single pass and then the group by?
Yeah, funny you should ask. Okay, let's bring this back. Let's try and get a little bit more serious here. So with rollup, again, it's going to assume a hierarchy there. So region, country, category, it's going to take that one pass. Cube is going to do every possible pass. So it's going to give me the total for region, the total for country, the total for category, the total for region and country, the total for region and category, the total for country and category, and the total for all of them. So it's going to give me basically every possible combination that it can have, which can sometimes be very powerful.
Yep.
And sometimes we want a little bit more control over how that's going to actually be rolled up. And that's where our grouping sets come into play. Before you go off and take that exam, make sure that you go back and double check that grouping set syntax, because when you first look at it, it might be a little bit funky, but you're going to trust me on this one. It is very powerful and definitely something that you're going to want to review. So if we take a look real quick at the query, what you're going to notice is inside my grouping sets, I now get to identify how I want each total to come together. So what I'm saying here is that I want the total broken down for the region, country, and category. I want the total for the country and category. I want the total for the region and category, and I want the total for the category. So I get a lot more control over how that's going to come together, and I get to do that inside of one query. And if you don't mind my throwing in a real quick exam tip here, that if you're ever in doubt when you're looking at a question and you've got a couple of possible answers, it's simplest thing that works. So if one of the possibilities is, all right, well, execute this query, this query, this query, this query to get all the totals, or I can do it just one time with my grouping set or one time with my rollup, do that. The other real big thing is you'll notice with cube and with rollup or with my grouping sets that I can get very explicit, or I can just kind of let it do whatever it is that it wants. Make sure when you're answering the question that you're just focused in on just the data that we want back and nothing else. Now, the next type of data that we need to work with, and again, something that not everybody winds up working with on a day-to-day basis, is dealing with XML. So if we take a look at a real quick sample query, you're going to notice that we've got raw, we've got auto, and then we've got a couple of others that we'll get to in just a moment, but let's focus in on our raw and our auto.
And now the key thing is when you're doing the XML queries that you always have to remember is when you're trying to remember difference, what you want to look at is whether they're generating the elements or the attributes, how they return the root element, and the nesting. Those are sort of the key things. That's what's going to differentiate the different XML query options.
Absolutely, and it's going to be what would differentiate the possible answers as well, so make sure that that's what you're focused in on. So what you're going to notice is a real quick example here that we've got our select first name, last name for XML raw. Now what raw is going to do by default is just give me row, 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 which generally speaking isn't overly helpful. So I can specify the value that I want for each row to be returned, the element name that I want returned for each row. And so you'll notice that I'm specifying contact. You'll notice that I'm adding in a root, because otherwise I'm just going to get back a document fragment. And then finally elements, because just as Susan mentioned a second ago, by default, of course, it's going to be attributes.
Yeah.
Now, the next one that we've got is auto, and I really kind of like this compare and contrast. Both the prior query and this one will get me back the exact same XML. The big difference is that with auto, it's going to go based on the name of the table. So if you want to change the element name, change the alias that you're using.
Yeah, so this way you got that element name of contact simply by putting an alias on the from clause instead of using the parameter on the for XML row.
Exactly, exactly. Yep. Now, the next two that we've got are explicit and path. And the big thing that explicit and path will give to me is a lot more control. It's all about control.
It's a good name, actually. For XML explicit, you have to be explicit in how you describe what you want.
Absolutely. Now, you'll notice that the syntax here is a little bit interesting, that you're going to notice that I get the ability to create levels. And so that's what the tag is going to be. I get to identify who the parent is. Then you're going to notice that we specify how we want each individual element to come back. So we're going to say product ID. You'll notice product, that's now going to become the name of my element. We're going to put it on level 1, thus the level 1. And then finally ID. And by default, just like with our auto and raw, it's going to become an attribute. So you'll notice there's my ID with attribute. If we want to convert it into an element, then you're going to notice that I call out element. So you'll notice that the XML down at the bottom is what I would get if I ran this query. On the flip side, with path, it uses XPath. Now, if you're anything like me, and I know I am, I really prefer the syntax for path. I find this a lot easier to read, that I just simply call out whatever I want the names to be. So you'll notice that I say name, that's now going to become an element. My product ID, I want that to be an attribute, and I use the @ sign for it to be attribute.
That's cool.
So the last little item to highlight, because you're probably familiar with top, which will get me back the top X. What about maybe I want rows 11 through 20?
Ah, yeah, trying to get rows 11 through 20 without...
Yeah, creating a CTE temporary, it gets a little bit tricky. So new to SQL 2012 is fetch and offset. What fetch and offset will allow me to do is specify the starting row and then the next number of rows that I want to get. So with offset, I'm going to say, well, I want to start on, let's say, row 11, and then with fetch next, that's then going to get me the next group of rows. So if I was paging maybe by 10 and I wanted the third page, then what I'm going to say is offset 20, so that's going to skip that 20 rows, fetch next, and that's going to contain 10. So I would say fetch next 10. That would then get me rows 21 through 30, so my next 10 pages.
Perfect. And
my next 10 rows.
And the one thing I really want to point out, a nice little exam tip too, is if you think about this, you wouldn't want somebody who's been working with SQL Server 2008 for 10 years to be able to walk in and pass an exam on SQL Server 2012. That wouldn't be fair. You should be able to work with SQL Server 2012 to be able to pass that exam. So how do you have an exam that doesn't let somebody who's been working with SQL Server 2008 for ages just walk in and pass? You have to ask questions about what's new in SQL Server 2012. So for me, I don't know about you, but every time I'm reading the requirements, when I see a new feature, a little light goes off my head saying, I'd better read up on that.
Absolutely, absolutely. Hey, Susan,
yeah.
If you don't mind, I'm going to put you on the spot here.
All right, go for it.
Okay, so Susan, you have a query. Query that returns data using the cube option.
Ooh, I don't use that often. Keep going.
All right, get yourself ready here. So one of the columns contains null data. You need to identify when a field is being used to display aggregated data. What should you use in your query? Because if you remember, by default, what's going to happen when it's displaying aggregated data? It's going to be showing null.
You're going to see a null value for the aggregations. Oh, so that I have actually run into this exact situation. I actually had this come up in a query. I mean, looking at this, you know, some of and this is one of those interesting ones because you look at it and go, oh, these are things that we can use for nulls, but I'm not. The problem is I'm going to get a null value back displaying in the column.
Yep.
I can't just change how that null value is displayed. That's not going to help me.
Nope.
So in this case, the right answer is going to be grouping ID because what grouping ID does is it actually tells you, it gives you a different value if the row represents aggregated data versus an actual null value.
That's exactly it. Congratulations.
Woohoo! I'm ready to go.
ID.
I can take that exam.
All righty. You know, we've done a lot of querying data here. Let's talk a little bit about actually modifying some data, actually putting it into the database, changing the values, doing things like that.
Sure. And I mean, let's not get into the update, insert statements, or assuming you guys know the basic syntax for delete, update, and insert. So let's jump into maybe stored procedures, which are of course, a great practice for updating and inserting data. And look at some of the options you have to think about when you're working with them. So things like the with encryption, we talked about that a little bit with the views.
Yep.
When you create a procedure, you have the option of specifying with encryption as well. And when you do that, that means if somebody goes and looks at the metadata, starts querying system tables, they will not be able to see the definition of your view. But of course, if you do that, make sure you have the code in a script somewhere, because you're not going to be able to get that command to recreate the procedure back without the script, because it is encrypted now.
Yep.
Then the execute as statement, and this is one that's really important to understand, because if you've decided for permissions, least security, that you're going to have users update data through stored procedures, you have to think about what permissions will people need to update the data.
Yep.
So the basic, if I create a procedure, if it updates a table, and then you want to run it, Christopher, then when you execute it, it's executing it with your permissions, then you'll run my stored procedure, and you're going to get an error message saying, hey, you don't have permissions to update that table.
Yep.
But I don't want to give you permissions to update that table, because that was why I created the stored procedure, was to control updates to a table. So that's where the execute as comes into effect. It's really important. So if I create a procedure and I say execute as owner, then when anyone executes that procedure, it'll be executing with the permissions of the one who owns the stored procedure. If you do it with execute as self, then it executes with the permissions of the person who is running the stored procedure, which is not generally
other way around.
So
with self.
Wouldn't be the first time.
Yeah, and that's actually, and this is a really good point, because it's one of those little tricky things.
Yep.
Because self and caller, you stop and you look at it, and the perspective is a little bit interesting there. With self, it's the person who's executing the create or the alter statement. So if I create the stored procedure or I alter the stored procedure with execute as self, that's now going to be as Christopher, while the caller is going to be whoever's calling the stored procedure. So if you said execute UP underscore, whatever the name of the stored procedure happened to be, then it's going to execute as Susan if it was as caller.
Right. Caller, it's executing as person who is calling the stored procedure.
Yeah.
Self is the person who created the stored procedure.
On the nose.
There we go. And then you have the ability to actually say execute as a specific user as well, but that's not as common. The other thing that you do occasionally run into when you get into performance with stored procedures is, of course, execution plans are created when you run a stored procedure. So for the next time you run the stored procedure, those execution plans are cached, so it'll run more quickly the next time. But depending on the data that you're passing into the stored procedure, there might be times when you would actually like it to use a different execution plan, because the type of data you're passing in just means, it's going to be more efficient with a different execution plan than the one it's been running with.
Yep.
That's what the with recompiled option is for. When you specify the with recompile, you're basically saying, when I execute the procedure next time, please recompile, reanalyze, come up with a new, fresh execution plan for it.
Yep.
Then we've, of course, got the update statement. Now, there is one thing about the update statement, and I love this feature, because I used to write tons of code that would basically say, go insert a record, and then I would write a select statement to read the record I just inserted. Or I'd update a record, and then I'd write code to read the record I just updated. You can do that in just a single statement using the output clause. So here you've got an update statement on the slide, a standard update statement, go update the product table, set list price to a new value, and then you see this output clause. And what that does is it returns to you the results of a statement. Now, we've done the update statement on purpose here because it allows me to show you, because with an update, you might want to see the original values and the new values. So when you ask for deleted name, you're asking for what was the value of name initially, and when you have inserted list price, that's going to tell you the new value of the list price. So when you use deleted as a prefix, it's the previous value. When you use inserted as a prefix, it's the value after the update or insert.
Yeah, and this is one of those little statements that separates the person who the person who maybe has just learned how to do an update statement, and the person who is, well, an MCSA, Microsoft Certified Solutions Associate. So that's going to be one of those differentiators. And so when you're studying, those are the types of things that you want to keep an eye out for. So anybody could go in and say update and then go back and do a select to get the value back out. The more advanced query writer is going to have command of that output statement, and that's going to be one of the differentiators that you'll see on the exam. So make sure that you go back and you study those. Speaking of differentiation, is the merge statement.
Merge is another great example of a differentiator for sure. A lot of times when you have a standard database and you've got a data warehouse, you have this sort of logic if you want to update your data warehouse. So you've got this table full of new customers, or new orders more likely. You've got a bunch of new orders that have been received, or new customers, and you want to go over to the data warehouse and say, hey, I've got some customers over here. If the customer is already there, update the existing customer record. If the customer isn't there, add a new customer. And a lot of times we would do that with if statements and stored procedures, but the merge statement basically allows you to do that logic in a single command. And actually, let's jump to the slide which actually is the code, because I think that's what's more significant here, is a syntax for this.
Yep.
So the way it works is you say merge target. So target would be the table you're planning to, which has the records you're going to be inserting or the records you're going to be updating. So that might be your data warehouse table. And then using sources, where are the records that I'm using to figure out what tables need to be inserted or updated? So that might be a table of order information in my transactional database. And then I have to say, well, how do I check to see if there's a matching record? So I'm going to look at the employee IDs in this case to see, is there a match between the two tables? And then I simply say, when there is no match, then do an insert. When there is a match, do an update. And that's the basic syntax. So it's pretty easy to read. That's one of the nice things about it. But we've added an extra clause here too, the output statement, which we saw in the update there, so I can see what happened when it ran. But what I really want to call out here is that $action command, because when you see that $action, that allows me to find out when the merge statement ran, did it do an insert or did it do an update? So I can find out whether it found a match or not.
Yep. All right, Susan.
I think it's my turn to pick on you.
All right, okay. What am I thinking, Cap?
All right, so you need to create a stored procedure to update rows in a table.
Okay.
The table's called customers. You have permissions to alter rows in customers.
Nice.
You need to ensure that all the callers of the stored procedure will be able to perform the operation even if they don't have permissions to access the table. So what option should you use when you're creating the stored procedure? And given that you corrected me on this, you better get it right.
Uh-oh. Uh-oh. Now I'm really on the spot. Okay, all right, so here we go. So kind of real quick, kind of talk our way through this here. Encryption and recompile, I'm thinking that those probably, I mean, recompile and encryption, that's not going to be it. All right, so it's the execute as. So now we've got the caller and the self. So once again, caller is whoever it is that's executing the stored procedure. Self is whoever's calling the create or the alter. So that's going to be execute as self.
Well done. All right, you dodged the bullet on that one.
That was close.
Okay.
All right.
So we got one section left to talk about, but we need sort of it's covered on the exam, and that's a question of, or the issues around optimizing the queries.
Yep. Yeah, and once again, that's going to be one of those differentiators, somebody who can make that query go faster and spot the different things that are going to potentially slow things down. And
really, you're not expected to be an absolute expert on database tuning on this exam.
Nope.
Really, they're just looking for, do you recognize, like, what are the better choices? Or when a query runs, what would be an execution plan where you go, ooh, if I'm going to focus on something to prove, I'd probably want to focus in on that one.
Yeah, exactly. Yeah, really just kind of knowing the hot spots, knowing the big things that you want to avoid. So for example, let's say that I bring up an execution plan and I'm seeing a join. And you notice the little icons in there.
Yep.
And I will tell you the type of join that it's doing. And so you'll notice that there's 3 different types of joins behind the scenes that it could be doing. So we could have what's known as a nested loop. And nested loops, generally speaking, are going to be used for small joins. Okay,
the tables aren't massive. You know, they've got your region IDs. There's only 10 different regions.
Yeah.
That's when you tend to get nested loops.
Exactly. Then we've got our merge joins.
Merge joins are the happy joins. We're always happy with merge joins.
Yes, and the reason for that is because all the data is already in the correct order. So I've got my customers in the correct order, and my orders are sorted by the customer ID. Real easy for SQL to bring that together.
Yeah. But then you have the, unfortunately, you think of the most common scenario, unfortunately, is the hash join.
And the hash join, the problem with that hash join is that that's going to be large unsorted data. So I've got my orders sorted by order ID, I've got my customers sorted by customer ID, and now we're going to try and join them together. So if you kind of stop and think about this, of course, in real life, how I would try and join that together manually, that's going to take me a little while. SQL's no different.
It does it faster than we would, but still.
Well, yeah, I suppose. A little bit.
But still.
But yeah, that's really going to slow things down inside of SQL, and one of those things that we want to keep an eye out for.
Now, transactions are going to affect performance as well, and that you do have to know.
Yeah, that you do have to know. And really, when it comes to managing transactions, first up about just managing them, there's 4 commands. So we've got begin, okay, start. We've got commit, all right, I'm done. Go ahead and write everything to the table. We've got rollback. Oh, wait a minute, something didn't work. Let's go ahead and...
the undo command, love rollback.
Yes. Oops. And then finally, last but not least, is save. And what save will allow me to do is to create a point that I could roll back to before committing the part that maybe actually worked earlier on.
Yes. Now, the other thing that's really important, again, we're talking about some of the transactions, and this ties in a little bit, is the isolation levels.
Yep.
Because, depending on how protective you want to be, or we're always going to have multiple users in the database.
Yep.
And if I want to make absolutely sure that nobody's touching the data while I'm reading it, I'd put a whole bunch of locks on my records.
Yep.
But that means you might get stuck waiting for your command to run because I've got everything locked away, and I'm like, you can't look at this because I'm modifying it.
Yep.
No, this is mine. You can't have it until I'm completely done.
Yep.
And it's the isolation level that controls whether I say, I'm modifying stuff. If you want to look at it while I'm modifying it, go for it. Or no, it's mine. You can't touch it. And then, okay, now you can look at it.
Yep.
So what do we got for the isolates? We got the read uncommitted.
Read uncommitted.
That is the, hey, you know what? I'm in the middle of modifying stuff. Go ahead and look.
Yeah, and the big problem, of course, is with read uncommitted is that while, yes, it's going to be uber fast, the problem is going to be that I'm going to potentially get bad data. So you're in the midst of maybe changing a customer name, and then you're over here going to change some associated orders.
And then I'm like, oh, roll back. I screwed that up. That's the wrong data.
Yeah, exactly.
And you saw the data, even though I didn't actually say save to the database.
Exactly.
I didn't commit it.
Yep. Yeah. So read uncommitted, going to be fast, but no locks.
Yeah.
Then you've got read committed, and read committed is the default.
Yep.
And the thing about read committed is that I'm going to be able to read only values that have been committed. But while I am reading it, people can go in and create any
inserts.
Yeah, they could actually create new records, or if maybe I've got a transaction and I do a select statement, and then I go back and I select that data again, somebody could have gone in and modified some of those previous values or inserted in previous values.
Yeah.
And we can avoid those two
with the repeatable read.
And the serializable.
That's right, yeah. So repeatable, well, especially if you look at things like those nested loops, the way they work is they go back to the same table several times. What prevents somebody from updating the table while I wasn't there? So when you do the repeatable read, what you're doing is you're making sure that's sort of controlling that situation where you're accessing tables. No one's done any updates while you're doing it.
Exactly. No one's done any updates, but somebody could have snuck in a brand new row. That's what's known as a phantom read, and that's where serializable comes into play. Now, the thing about serializable is that not only do we have to protect the data that we know about, but we now have to protect the data that we don't know about. Basically, kind of unknown unknowns, if you will. And so with serializable, SQL needs to get very aggressive with the locking, and depending on my indexes that I might have behind the scenes, SQL may actually need to lock the entire table.
Yeah, so meanwhile, I'm over there trying to run a query, and I'm being, I'm waiting and waiting, going, boy, this query's slow, and it's because of a locks he's got on his table because I chose serializable. So that's the gradation you have to think about.
Exactly.
Now, snapshot isolation is a nice option as well, though.
Snapshot isolation is very nice. Well, the way that snapshot isolation works is that I go in, I start modifying data, I start reading data, and I'm going to get my own little sandbox that I can play in. Now, SQL behind the scenes is going to use versioning, it's going to use tempdb, and it's an option that needs to be turned on because of that. But what's nice is that I can go in, I can play with my data, and other people could go off and play with their data, and we're not going to impact anybody unless maybe I went in, I read some data, Susan went in, she modified that data, but I've got my own little sandbox, so I didn't see that. I didn't know anything. And I go, oh, wait a minute, this is bad. And I want to go in and I want to change the value. I issue an update statement. Well, now SQL's going to go, well, wait a minute, you're about to do something to this data. You don't know yet that it's been changed, and so it will error out. So you do have to be very careful with error handling when you're doing update. And the last little thing to note about Snapshot is that if you decide that you want to change the default on the database to use snapshot isolation, you can do read committed snapshot. And what that's going to do is change the default to use snapshot. Now, speaking of those errors, how are we going to handle errors?
Handling errors, got to do that. And of course now, and this is one of those nice ones for all those people who've been working with .NET, this is a really easy one. We've got try-catch in SQL now.
Yep. Yeah, what try-catch is going to do is it's going to give me the ability to say begin try. And the way that I always like to say this is it's basically just do this, do this, do this, do this. And by the way, if something goes wrong, let me know. That's exactly what try-catch is going to do. So I've got begin try. I'm going to start up maybe a transaction, and I'm going to do my work assuming success. I'm never going to get to the next line unless the one before it succeeded. So the only way that I'm getting to my commit transaction is if everything else worked. If it didn't, then we're going to wind up inside of the catch block. So of course we'll roll back the transaction, and then we can go get the error message, the error number, the name of the stored procedure under error procedure, and then finally error line.
Yep, exactly. You know what, and the other thing we should just touch on is cursors before we wrap up, because that is another one that's, I think, important to cover.
Yeah, and really mostly just to say avoid cursors.
Yeah.
Because what cursors will allow us to do is give us the ability to go through row by row by row, which sometimes, on very rare occasions, can be good, but SQL works best with set-based logic. So you'll notice on there that we've got the steps to use a cursor. The big thing really that I want to mention as far as getting ready for the exam goes is be very careful about using cursors. So if you see a question, hey, you need to do this, and one of the options is to use cursors, be very careful about choosing that one, because generally speaking, that's not going to perform as well. And whenever you're answering questions, it's basically always, what's going to make this go fastest? It'd be kind of silly to test somebody, hey, how can you make this query go slower?
Yeah, so you really better be able to justify the choice of the cursor if that's what you're selecting.
Exactly.
Now, that ties nicely to hints, too.
It does.
Because when I have the option of using a hint as a way of improving a performance, generally speaking, the optimizer is really, really well written. Let SQL Server figure out the best way to execute the query.
Don't outsmart the optimizer.
Yeah, so really a hint is really a last resort where I'm running into a situation where there's no way the database can figure this out. I have one person who convinced me of a situation once where they needed a hint. They were looking at data in Canada, actually, by sheer coincidence.
Yeah, weird.
And they noticed that cities in British Columbia are north and south, and cities in most of the other provinces tend to be along the XY, or if well, along east-west, along the American border. So as a result, when they were querying in British Columbia, they actually wanted to use Y coordinates, and when they were querying in other provinces, they wanted to use X coordinates. That was a situation where they actually used a hint. But generally speaking, let the optimizer do its work. But you should at least know the syntax.
Yep, absolutely. And so you'll notice on the slide here that we've got our query hint, which is where I'm going to suggest how the optimizer should execute that query, so I can tell it specifically that I'm looking for different values, or, and this is actually one of my favorite little options, the unknown, where I'm going to tell SQL basically kind of prepare for any possible value that might wind up inside of there. And then down below, you'll notice that we've got our table hint, which is where I could tell SQL how I want it to lock the data. So you'll notice, for example, that we've got tab lock, which would actually tell it to lock the entire table while doing this. And obviously with query hints, just like Susan mentioned, I could lock the entire table while doing my query. That's a pretty big stick to swing there. So you do want to be very careful about that.
So I think that's, with the time we've got, we've done a pretty good job of covering a few things. We certainly haven't covered everything, but let's just do a quick review. So we've identified our certification goals.
Yep.
Right? So your certification goal, at this point, if you're listening to this session, you're going to be taking the 461 exam first, and your goal is probably to get your MCSA on SQL Server 2012. Finding the gaps in your knowledge, that's really got to be up to you. You've got to look at the exam objectives, go through them, and see what it is you don't know. Then fill the gaps. Hopefully we filled a few in for you here today, but you're still going to need to probably go and do a little studying on those areas you don't know, and then you're ready to take the exam.
Yep. So when you're ready to take the exam, first big thing, set a date. So that way you're not going to go, oh, I'll get to it, I'll get to it, I'll get to it, I'll get to it. Because let's just be honest.
I'm not ready. You'll keep telling yourself, I'm not ready yet, I'm not ready yet, I'm not ready yet.
Exactly, yeah.
There comes a point you just have to take it.
Yep. Set small goals. So rather than trying to learn everything within a 3-month period, set smaller bite-sized chunks. So by the end of this week, I'm going to understand how to query XML. By the end of next week, and I'm going to update or understand how to do like output and the merge statements.
Right. Get a good night's sleep. Honestly, cramming till 3 in the morning is probably not going to help you as much as getting a decent night's sleep the night before.
Absolutely. During the exam itself, don't panic.
Oh, so true. Yep. Honestly, I have taken exams where I walked in and the first 5 questions, I'm like, I don't know, I don't know, I don't know, and I start freaking out. And then I go through and I'm like, oh, but I knew the next 5 questions. So don't panic. Just plow through it. Finish that exam. You might be surprised. You might see a 700 when you're done.
Absolutely. After all, nobody's going to beat you with a stick, so don't panic.
We did mention you'll have 2 to 3 hours to do the exam. Do keep an eye on the time. Maybe when you're done like 20 of the questions, take a glance, see how you're doing. But don't feel like you have to watch.
Yeah, don't focus on it. And you know what? Speaking of time, the score doesn't change depending on how fast or how long you take on either an individual question or on the entire exam. So take all the time that you need. As we talked about before, we've never met anybody who said, you know, if I would have had 10 more minutes, I would have passed.
Yeah. And when you hit a question that you look at and go, I just don't know the answer, just apply a few strategies. Are there answers you know and you go, well, I know it's not that. Well, now you've narrowed it down to 1 of 3 or 1 of 2. That's one good strategy. Yeah,
another one is just mark the question for review. You know, go back after the exam and take another look. Maybe something will have triggered your memory. And you go, oh, okay, that's right. I remember that was. But I do want to say one thing about that. When you go into that review section, be very careful about changing answers. The number of times when I have talked myself out of the right answer that I just overthought it, your first instinct is almost always right. So just be very careful about that.
And the last one, of course, is just guess. There is no penalty for guessing. Like, it's not like you lose 2 points if you guess the wrong answer and get 1 point for guessing it right.
Yep.
So if you don't know an answer, guess.
Yep.
It's better than leaving it blank. If you leave it blank, there's no chance you got it right. If you take a guess, maybe you get it right, and maybe that's what makes the difference between the 680 and the 700.
Yep. So if you're ready to go out and register for that exam, you can head on over to www.prometric.com. And if you decide, you know what, I need to get a little bit more ready for the exam, you'll notice that we've got the link to the exam page itself. Microsoft, of course, does have courseware on the product, so if you want to get in-person training, you could be on the lookout for course 10774.
Might run into you.
Exactly. And then finally, of course, a couple of books to call out. The training kit, which is geared towards the exam, and then you'll also notice the T-SQL Fundamentals, which is just an overall, hey, this is how to go in and query fundamentals.
And I think with that, folks, you guys are ready to go rock the exam.
Good luck.